Hi, everyone. My name is Andrew Atkinson, and I'm a software engineer and book author. I help companies with Postgres and Ruby on Rails. And my talk today is called SaaS on Rails on Postgres. It's all about building multi-tenant SaaS applications and the capabilities that we have to scale up and scale out with things like Active Record, Horizontal Sharding, and Citus. And this talk is really going to be aimed at back-end engineers using Ruby on Rails and Postgres, DBAs, and infrastructure engineers. Okay, so the overview of the presentation is, first we'll define some terms so that everyone's kind of on the same page. We'll look at SaaS, multi-tenancy, data isolation, and sharding. We'll be working with a multi-tenant SaaS B2B Rails app that uses Postgres, and we'll explore some options for scaling up with traditional Postgres. And then we'll also look at recently added capabilities in Active Record and Citus later in the presentation. And we'll look at options to scale out beyond a single instance. So for those unfamiliar with Ruby on Rails, let's just provide a little background on that. So first we have the Ruby programming language, which was created back in 1995. It's open source, it's a general purpose language, and it's implemented in C like Postgres. And then the Ruby on Rails framework came around back in 2004, almost 20 years ago. And it's a web app development framework. And then within Ruby on Rails, we have Active Record, which is most commonly associated with the ORM, but it also provides capabilities for managing the schema as well. So if we add columns and that sort of thing. And then Active Record has multiple databases support recently, including some newer capabilities around horizontal sharding, which we'll look at. So in our scale out overview section, we're going to move beyond a single primary Postgres instance. And we're going to look at Active Record horizontal sharding and look at Citus. I did want to call out this great visual website called Database Sharding Explained by Mahdi Yusuf, which is linked here, which has a lot of great diagrams about these different sorts of architectures. Okay, so we're going to work with a Rails application called Rideshare. It's a Ruby on Rails app using Postgres. Currently, it's not set up as a multi-tenant application, and it's just using a single Postgres instance. And some of the code samples that we'll be referencing in this presentation are available at that repository URL if you go to pull request 198. So folks are probably familiar with Postgres, and we introduced Ruby on Rails a bit. Let's just talk briefly about software as a service and some of the terms there. So software as a service is a delivery model, and SaaS apps typically generate or typically receive and process a lot of data. So there is some architectural planning that's required to process all of that data while still offering good performance and availability. Customers for SaaS apps could be businesses, which we would call B2B, or consumers, which we would call B2C. And B2B SaaS apps might have customers in the dozens, hundreds, or thousands of sort of range, where business to consumer sorts of apps might have thousands or millions. So it's worth kind of thinking about your customer profile. And SaaS apps are going to have common needs: authentication, profiles, plans and subscriptions, and other items here on this slide. And we're not going to really get into these as part of the application design, but I did want to recommend for those that are unfamiliar with these, within Ruby on Rails, there's a number of great software packages that can be added: Bullet Train, Jumpstart, Rails, and Business Class, which address some of these common needs, where if you're getting a new Rails SaaS application going, this could be a great place to look to help accelerate your development. So we have a Rails SaaS application, and we want to add multi-tenancy to it. So for our tenants, we're going to actually call them companies. Tenants is a general term that could mean companies, accounts, customers, and we're going to use the term companies. So we'll have a companies table where when we add new companies to our platform, they'll have corresponding records. And then for table data that is related to that company, they'll have a company ID foreign key column on those other tables. So what if we weren't using multi-tenancy? Well, in that case, we would likely, as we add new companies to our system, we may want to, if we needed to isolate their data and possibly their compute, we would create a new database to store their data, and then we would optionally run that database on an entirely separate instance for that company. And while that does give us greater isolation of both the data and the compute, we're going to incur more infrastructure costs to run that separate instance or more load on our current instance. And then we're going to incur more of a maintenance burden if we're running multiple instances. We need to monitor them, we need to upgrade them, that sort of thing. So let's continue on with adding multi-tenancy to Rideshare. So we'll add a companies table, and we will be adding this company ID foreign key column to our table data that we now want to associate with specific companies. So for example, one of the tables in Rideshare is called trips, and here we see company ID being added with a foreign key. And what we're trying to do with multi-tenancy is we're trying to gain efficiency in our infrastructure with fewer tables, database schemas, databases themselves, and server instances. And besides that, we're trying to gain flexibility as well. One of the advantages to building in this tenancy information is we can more easily identify our tenant data, and that can give us flexibility later if we want to move tenant data to its own instance, if we want to copy tenant data to a lower environment. We may also have external legal requirements for our tenant data, and again, being able to easily identify it is going to allow us to have some flexibility there. Besides identifying the data, we may want to limit access to certain tenant data. Postgres, let's explore some native capabilities with Postgres. So Postgres has row-level security built in, and what we would do is we could create a role or a user object for our companies, which are our tenants, and then we could create a policy per table where we want to limit access that checks the current company ID against the role that is accessing the company. And by using this combination of roles and policies, we can then limit access to the table. Again, our client application will need to set up to use the proper role when it's accessing the table. And if you want to check out a bit of code samples here related to role level security, check out the pull request I mentioned earlier. So we're still exploring some of the capabilities with traditional or single instance Postgres before we go outside of that. But since we are running on a single instance, we might run into some challenges. What are some of those challenges that we should anticipate? Well, we can't really allocate our instance resources like CPU cores, memory, IO operations to our individual tenants. And we'll have a shared set of additional resources like database connections and a single buffer cache, also called shared buffers, that will contain data from different tenants. So our observability for tenant operations might be more challenging because we're working within the single instance. We may also need to significantly over-provision our instance if we have really variable workloads between our tenants. An optional thing on the schema side, again, we're still working with a single database, is moving to composite primary keys. So currently we have traditional single column primary keys defined, for example, for our trips table. What we could do is change our primary key definitions to include the company ID that we've added. And it's worth mentioning that composite primary key support was added to Active Record 7.1. So with our Rails application running that version, we'd be able to take advantage of that. An example of what that would look like here is in the top is a traditional setup with a single column primary key, and on the bottom we have a composite primary key with the ID and the company ID. Another capability in Postgres we could leverage for our multi-tenant design is table partitioning. And if you're not familiar with table partitioning, there's a few types that we can choose from. What we're looking at here is the list type. And what we would do is we could create a partition per tenant, or per company ID in this case. And what we would do then, besides creating that partition, we'd make sure that all of our queries in our client application have that company ID column as part of their conditions, which is our partition key. And we are going to run into some caveats that we'll need to work through, such as if we have existing unique constraints and we want to be aware of increased planning time as we add more partitions. But our big benefit here for multi-tenant apps, if we've identified our tenants and they each have their own partition for data, is later on we can more efficiently and easily detach their data and archive it if they're no longer on the platform. And we can do that using the detach concurrently operation, which was added to partitioned tables in Postgres 14. So again, within single instance Postgres, we also can create schemas per tenant. So in our case, if we're adding new companies, we might create a new schema object. And within that schema, we'll have that company's tables. And the data in those tables would be specific or exclusive to that tenant or that company. And in that way, we can also even limit access to schemas. So let's look a bit outside of Ruby on Rails itself and Postgres itself. We can bring in another Ruby gem. We're going to look at two Ruby gems here. One is called actsastenant. If you're not familiar with Ruby gems are the shared library code in the Ruby ecosystem, and they can be added to existing Ruby applications. So actsastenant gem is going to help us with that row level multi-tenant data. So again, in our trips table from earlier, where we have a company ID column, we can set up actsastenant to work with that. And then apartment Ruby gem, it's not as well maintained based on what I looked at recently. So I put a little warning there, but it offers us schema-based data isolation. So if we do pursue a design where we've set up a schema per tenant, we might want to look at the apartment gem. So this is a little bit of a table representation of a recap of some of the things we've seen so far. So we're working within the same database on the same instance, and we're considering mostly data isolation here. We looked at table partitioning, which if we set up list partitioning and we have tenants identified as with their company ID column, and we've set up partitions per company ID, then we have kind of row level data isolation. We've looked at per tenant schema designs where we'd create a schema for each company that we add to our platform. And then we looked at two Ruby gems, apartment gem, which adds that schema isolation, and actsastenant gem, which adds that row level support. And then we looked at row level security in Postgres, which allows us to add a security layer on top of row tenant data. So with that covered, then we've covered a number of capabilities related to traditional Postgres. And what we'll do next is look a bit beyond single instance Postgres. Before we do that, though, it is worth mentioning with Postgres, we have physical and logical replication options. So it's worth exploring that because we'll have a less complex topology. And with physical replication, we can send some of our workload there. We can send our read-only queries to our physical replicas. And there's even some interesting new capabilities with logical replication where we can take advantage of active-active replication with bidirectional replication. There's an example I have here linked that shows how to avoid primary key conflicts where you're receiving active writes on two different logical replicas instances. But this all being said, these are still the capabilities with kind of traditional single instance Postgres. We don't have multi-primary type of capability or sharding capability. There is a wiki page on the Postgres wiki about kind of a work in progress sharding design using foreign data wrappers. That's interesting. But we don't have this capability natively currently. And for that reason, it means row level or schema level sharding, where we might distribute pieces of our database to different nodes, isn't available to us out of the box with Postgres. So let's look a bit beyond. We'll look first on the application side. So the Active Record Framework, like we discussed earlier, it gained this new feature called Horizontal Sharding in 6.1, which was released in 2020. So horizontal sharding is a generic mechanism or a general purpose mechanism that allows you to set up shards how you'd like to define them. And what we can do with that is we can apply a multi-tenancy design to shards. So we could create shards per tenant or per company in our case. And with that code, those code samples I mentioned earlier, there's a bit of the demonstration there if you'd like to check that out. Here we'll just set up a company one shard, which is what's listed here. And in this case, what we're going to do is the kind of routing and mapping aspect is all going to occur in the application. So the Rails app will identify a tenant, and we're going to look at an example where it uses the HTTP request subdomain to do that. And we're going to have a setup where for each shard, we'll have a shard per company or per tenant. And those are going to be different databases with our application. Each database is going to have the same schema design. And these shards could be run on the same instance. However, for greater scalability, what we could do is run the databases on separate Postgres instances, all being read to and written from the Rideshare application. So these are just some real basics about how you might go about setting this up. These are mostly just from the active record documentation. We have a shard record Ruby class on the top that's going to have our shard configuration. And then with with active record multiple databases support, we've already configured in a YAML configuration file all of our connection strings to all of our different databases. And what we're seeing here is our company one shard. It's got both a writer or a writable database, and then it also has its own replica, which we can configure. And then in the bottom code portion, we see this shard selector, which is functionality that's built into Horizontal Sharding, and then this shard resolver. And what that's doing is it's taking the request subdomain, it's looking up the company, which is our tenant, and it's finding the company shard. And then we're going to keep that information throughout that session. So horizontal sharding is one option with application level sharding. Another option is Citus. Citus is a distributed Postgres deployment for horizontally scaling. And here what we're going to be doing is looking at sharding at the Postgres level. So we're going to have a series of nodes, and nodes will have a coordinator node, and then we'll have one or more worker nodes. And shards can be placed on the worker nodes. And as we add more worker nodes, we may want to reshard so that our shards are evenly distributed amongst our worker nodes. Citus is an open source extension. Some people call it a super extension since it changes the operational model quite a bit. And besides running it on your own, you can also take advantage of hosted services like Microsoft's Azure Cosmos DB or Crunchy Bridge. So Citus has some new concepts to learn. It has the concepts of distributed tables that we'll look at. And the code samples here are on the newest version available of Citus, which supports identity columns. And here we're setting up, again, our companies table and our trips table using identities. And we're going to look first at row level sharding with our company ID. And like we saw earlier, we've already kind of designed for multi-tenancy. However, if we hadn't done that, we would need to do something similar here and add this company ID tenant identifier column. Citus calls that a distribution column. And it's important to do because with that information, then Citus can take advantage or can perform a co-location functionality to make sure that shards are on the same nodes that have the same distribution column. So besides distributed tables, we also have reference tables. And reference tables are going to be, here what I've done with Rideshare anyways, it's going to be our smaller tables that will be replicated to all workers. And there are some caveats around changing primary keys and foreign key definitions. And it's also worth noting there's another Ruby gem called Active Record Multi-Tenant that adds Ruby helpers for some of these SQL functions that we get from the Citus extension. So on the top here, we see we're creating two reference tables using these functions, create reference table and create distributed table. On the bottom, we're creating distributed tables for the trip request table and trips, both specifying our company ID distribution column. It's really important that we also change on our application side. We make sure that the distribution column or our tenant identifier column is always part of queries. On the top in red, I've shown how if we don't do that, we'll have a much slower query because each shard will need to be checked for whether it contains the data or not. on the bottom, we've set the company ID. And in looking at the SQL that's logged on the instance, we can see that it can immediately go to the correct shard for that table behind the scenes, and it's a fast query. So that was row-level sharding, just the very basics of it. And Citus last year in 2023 added a second option called schema-based sharding. And with schema-based sharding, we don't need the distribution column that we've been talking about. Instead, what we do is we create a schema per tenant, and then the schemas themselves become the shards. So the tables in the same schema are then also co-located on the same node, and that way join operations and foreign keys work like how we would expect. So what we see here is we've enabled the schema-based sharding option, and then as an example, we've created two schemas for two different companies, and we could then use the search path in Postgres to make sure that if we don't have schema qualified tables, we are reading and writing to the correct tables. The client application would need to do that, or we can also use schema qualified tables. So here's an image from the Citus blog. This is just showing two worker nodes on the left and right. And then on each worker node, we see three schemas on the one on the left and two schemas on the one on the right. And each of those schemas map to a particular tenant. And then within those schemas, we have three database tables: messages, threads, and users. So this is just showing a bit about how we might distribute our schemas across our worker nodes. So that's our brief look at different sharding options. Let's just recap a bit. Horizontal sharding in Active Record is going to be application level sharding, and it's going to allow us to separate out row data for our different tenants, which are companies in our example here, to their own databases, and those databases could run on their own instances. And the application is going to be responsible for identifying the correct shard, sending reads and writes to the correct place, and that sort of thing. Or alternatively, we could then, we could make a different choice where we decide to shard at the Postgres level by using Citus. We have two options there, row-based or schema-based, and that's going to be outside of our app for the most part, apart from distribution column query changes. And then we can either create schemas per tenant or per company, or we can identify rows and take advantage of row-based sharding. So let's wrap things up here, and I can provide a little bit of generic advice. With single instance or single primary Postgres with replication, we can take things very far in terms of scalability. And the benefit there is we retain all the normal sort of functionality with primary keys, foreign keys, join operations. And these days, it's possible to get quite large instances with CPU, cores, memory, I/O operations. That being said, we should collect usage metrics about our query patterns, our data growth patterns, especially for shared resources on our instances, like our CPU, cores, memory, connections. And we want to identify those patterns in that data growth, and we want to measure its performance and plan for future states. And we want to consider costs, both infrastructure costs and engineering time, if we adopt one of these distributed database technologies. So some additional considerations here. Consider designing for multi-tenancy, even just to make identifying your tenant data easier, because in my experience, that gives you a lot of flexibility to move data around, copy data, that sort of thing. Depending on how you're hosting Postgres, check for its extension support. If you wanted to use Citus, it would need to be a supported extension. And then consider app level and Postgres level solutions and how they match the skills on your current team and sort of the maintenance plans your team would have, or how you might acquire those skills outside your team. And keep in mind that your application schema design will evolve. So with distributed databases, we'll be needing to make those incremental changes to every copy of our database, and that's going to be a bit more complex. So keep that in mind as well. Here's a lot of the resources that I used for this presentation today to prepare for it. These will be available to you. And I just wanted to quickly mention that I have written a book called High Performance Postgres for Rails. It's available for sale now from Pragmatic Programmers. Thanks for your time today for watching this. I'd love to connect on Twitter, or LinkedIn. I've also got an email newsletter at pgrailsbook.com, and I also blog at andyatkinson.com. That's all I've got for you, and thanks again.